In this video, I'm going to talk about area under the polar curve. In particular, I'm going to talk about this polar relation. R is equal to 6 cosine of theta. Now, you probably already know this is actually a circle. So let's go ahead and draw XY coordinate, and this is how it's going to look like. So let's sketch it here. Okay, so this is the center 3 and this point 6. Now in polar coordinate, how do we get the area under the curve or area enclosed by the curve? This is given by this formula. A is equal to integral a to b 1/2 r square d theta. Now I'm going to evaluate this integral. So let's go ahead and do that. So integral 1/2 r. R is 6 cosine of theta. If I square it, it's going to be 36 cosine square of theta d theta. Now you kind of have to figure out what is a and b. That means lower limit and upper limit for integration. You can see that this goes from negative pi over 2. So this is negative pi over 2 to pi over 2. So it's going to be from negative pi over 2 to pi over 2. So if I continue with this, it's going to be integral negative pi over 2 to pi over 2. The integrand is 18 cosine square of theta d theta. Now this I'm gonna kind of break apart. So I'm gonna take a 9 outside. You will see why. Negative pi over 2 to pi over 2 cosine square of theta d theta. Now you remember cosine of 2 theta is equal to cosine square of theta minus sine square of theta, which I could simplify to cosine of 2 theta is equal to 2 cosine square of theta minus 1, or equivalently 2 cosine square of theta is equal to 1 plus cosine of 2 theta. And that's why I kept 2 cosine square of theta inside the integral. So if I continue with it, this is what I get. 9 integral negative pi over 2 to pi over 2. 2 cosine square of theta is 1 plus cosine of 2 theta. Cosine of 2 theta d theta. Now that's going to be 9. Integral of 1 d theta is just theta. Integral of cosine of 2 theta is 1/2 sine of 2 theta, and that needs to be evaluated from negative pi over 2 to pi over 2. And if I do so, I get 9 times theta is pi over 2 minus pi over 2 plus 1/2 times sine 2 theta. So 2 times pi over 2, which is just going to be pi, and in essence it's going to be 0 too, right? Sine pi 0 minus 1/2 times sine of negative pi over 2 times 2. Actually there is a 2 here, and by the way this is also going to be 0 because sine of negative pi is going to be 0. So now if I ignore this one and this one, so this goes to 0 and this goes to 0. So I'm left with 9 times pi over 2 minus pi over 2 is just pi. So this is going to be just 9 pi. So the area under the curve in this case is going to be A is equal to 9 pi. Which kind of makes sense. Area for the circle is going to be area is equal to pi times r square, right? Pi times r is 3, so 3 square, which is 9 pi, exactly what we expected. So we got exactly the same thing. I hope that this discussion was helpful. Thank you very much.